units or components for small UAS in order to help feed both what is happening within the Army, but also commercial industry, because as you know, about 85% of small UAS parts are manufactured in China or Taiwan, and we believe that's a strategic risk for our country. And so we're manufacturing small brushless motors. We're manufacturing small wiring harnesses. We also 3D print microelectronics and circuit cards all ready for radars. And so we're going to do the same thing for small UAS with the ability to feed our tactical units parts that are part of the controlled supply chain, so that they can manufacture those small UAS and assemble those small UAS at the point of need. That's just one example. The other is what we're doing with digital twins. And so we are building a digital twin right now of the M88 at one of our industry or our actual academia partners. They're disassembling an M88 part by part. They scan it, they test the material qualities, so that we have then a file of parts that we can rapidly manufacture at the point of need, either at one of our depots or arsenals, one of our industry partners. We're building a network of industry capability, or if they have the right kind of machinery, all the way down at division or even brigade level. And so having those digital files is incredibly important, and that's just another example of how we're rapidly advancing advanced manufacturing.
Yeah, and that's just a unique concept to see. Like, we see at small scale that they're showing off some 3D printing downstairs, and that's of course the small scale of it. And a lot of times that's what people think of. They hear advanced manufacturing, that's all I think of, is just 3D printing, and that's it. But there's so much more, as you just described.
Yeah, so we do, we 3D print titanium parts. We do laser powder bed fusion as well with massive industrial quality machines. We also have the world's largest 3D printer at Rock Island Arsenal that can print. It's called the jointless hull printer that can actually print an entire vehicle hull out of aluminum.
Wow.
Yeah, it's a massive machine. And then all the way down to some very small capability that will be integrated in with the MWMSS, which is a tactical capability we have at the brigade level. But key to all is the digital repository of files and the digital linkage between each echelon of capability, which is probably the hardest part, is linking all the machines and the files together.
And that's the key.
That is the absolute key.
So say I'm a junior soldier, maybe I'm a junior mechanic, or maybe I'm like a young company commander.
Yeah.
What should I expect to be able to see with this?
Yeah.
Kind of.
And so let's you have a deadlining fault on M88. Pick a system. We've also done the 777, the Bradley, or we're getting ready to do the 777. We've done the Bradley, the H-64, the UH-60.
Wow.
And so we're building these files out. So imagine you have a deadlining fault for some kind of wiring harness or a hard part, right? A bracket. You look in the supply system. That part is not available in the supply system. But at the same time, your Allied Trades warrants are scrolling through the 026 report, and you're scrolling through, and you see that deadlining fault. You see that it's a back order status. And then you do a quick search of the digital repository that we've established, and you see, oh wow, I can manufacture that part. Here's the digital file. I have the right kind of machine and the right kind of material. You can print that part, or fabricate that part. Cut the parts on a water jet printer, because advanced manufacturing is more than just 3D printing, right?
Yeah.
So you can cut those parts on a water jet printer. You can weld them, certify the welds, and then put that vehicle back into operation. In the future, right now, there's a lot of manual touch. In the future, actually, we had a session yesterday. We need to have AI agents that are constantly crawling through our data that will automatically slew those parts or that requirement over to advanced manufacturing when it sees that there's a back order status for a repair part.
Just as we talked about, the time it's saved, the money that's saved by doing this. We're we talk about in-house or just at higher levels, and what that's bringing to the warfighter, and just be able to keep that warfighter in the fight longer. A system goes down, we can get that system back up much quicker now.
Yeah.
So
Yeah, and there's also another important aspect of it that we're using data to do is, and that's our telemaintenance efforts that we do. So, for the past several years, we've been heavily involved. AMC has been heavily involved with our Ukrainian partners, helping them diagnose and fix, donated equipment that they're using on the battlefield right now. And which started out with an Army warrant officer and a couple of NCOs doing it via phone calls, grew to a telemaintenance capability that we now are spreading across the Army that will allow those video chats, allow the basically the passage of depot level skill sets down to the operational force, and think about a widely distributed battlefield that is very lethal. Being able, instead of sending LARs or sending depot maintainers forward, you can pass those skill sets down. And then if you need special tools, you could potentially fabricate and 3D print those special tools based upon the digital repository that you have access to on tactical communications. And so we see a significant increase in maintenance capability